Okay, okay, thank you. So in last two lectures that we have seen, we have started hypothesis testing. So last lecture, hello, are you able to see screen? Okay, so are you able to see the PPTs? Okay, okay, fine. So let's move. So in last lecture we have seen the in hypothesis testing the types of error. So I will recall this in 2 minutes and then we'll go for next part. So there are two kind of errors that we are having: type 1 error and type 2 error. So type 1 error is going to be occurred if your null hypothesis is rejected when it is true. So your null hypothesis is actually true, whatever result that is stating, that claim we are making, that claim is true, but we are rejecting that particular hypothesis. So this is referred as a type 1 error. This the another kind of error that can be occurred in hypothesis testing is type 2 error. If the null hypothesis is not rejected when it is false. So these are the two possible errors that can be occurred as we are assuming, as this is the process of prediction, as this is the process of assumption, and we are trying to prove that. That's why these kind of errors can be occurred in this particular process. Then how to identify that example that we have seen, how we can identify the type 1 error and type 2 error, or what will be the serious cause that can be occurred by type 1 error or type 2 error. So this part we have seen. Then we have seen level of significance. So what is meant by level of significance? The level of significance is nothing but what the maximum probability that making type 1 error, or it is a probability value that we will able to commit that type 1 error. So this is referred as alpha. So that we are having, and there are three possible standard values for this level of significance that already we have noted, that alpha equal to 1%, 5%, and 10%. So the actual values, 1% means 1 divided by 100, that you are getting 0.01. If you are considering 5%, then 5 divided by 100, then you are getting 0.05. And 10 divided by 100, then you are getting the value as 0.10. And if any level of significance is not stated in the exam or in while solving the problem on hypothesis testing, if this level of significance is not stated or not mentioned, then you have to always use the default value for a level of significance is 5%. So the value that you have to use is alpha equal to 0.05. Then we have seen the different types of tests. So basically there are three types of tests that you know or you are aware about this. First is a Z test. So when to carry out this Z test? So Z test is we are carried out when our sample size is greater than 30, or the at least sample size should be 30. Then only we have to use Z test. So there is a mathematical formula and statistics for computing Z test that we will going to see when we are going to solve numericals based on this. So this is the first test that we are going to be carried out for checking hypothesis testing, Z test. This test is carried out when your sample size is greater than or equal to 30. Like your sample size is 60, your sample size is 100, your sample size is 1 lakh, your sample size is 2 lakh. If, like this, if you are having, then you have to use the Z test. There is another kind of test. That test is referred as a T test. So when to carry out this T test for hypothesis testing, when your sample size is less than 30. That means your sample size is 10, when your sample size is 5, when your sample size is 29. Like this, if you are having, then you have to carry out T test. And there is another test that we have seen, that is chi-square test. So when we have to carry out this particular test, so this test we are carried out when there is an unknown variance, there is unknown populations. If there is unknown mean, you cannot able to calculate mean, you cannot able to compute the population strength. At that time, so you need to be perform this particular test, that is chi-square test. So these are the three tests we need to use for checking your hypothesis claim, checking your null hypothesis is true or false, whether we need to accept that particular hypothesis or we need to reject that particular hypothesis. To test that, any one test is carried out based on the situation, based on the use cases that we use. We have to choose any one test. Then we have seen p-values. So what is meant by p-value? So p-value is nothing but probability value that yesterday we have seen. This indicates that it is a probability that your null hypothesis is true. So this p-value table, already I have said that there is a table, the p-value table for Z test. p-value table for t-test, and p-value table for chi-square test. So these are the three tables that you have to refer, and this p-value you have to choose, and based on this p-value you have to conclude your inference, you have to conclude your claim, you have to conclude your opinion, you have to conclude your prediction, whether it is true or whether it is false. So you require p-value, and you require any test value, that is z test, t test, or chi-square test. This value you have to require, and you have to compare this value, and based on this comparison you need to make conclusion. So this is a p-value that we have seen. Then we are having three kind of tests. That first test is left-tailed test, second is right-tailed test, and third is two-tailed test. So these are the three kind of tests that we have seen yesterday. So this is first test, that is left-tailed test. So it indicates that in your alternative hypothesis, we are having two statements, null hypothesis and alternative hypothesis. So in alternative hypothesis, if inequality symbol less than is occurred, then that area of portion for p-value is occurred at left-hand side. That's why we are seeing this as a left-tailed test. That means the area which we are interested, that area occurs in your bell shape or your normal distribution curve. So if you see this particular graph, so in this graph is referred as a bell-shaped graph, or you can refer this as a normal distribution graph. So how your population, how your data is distributed. So that graph is referred as a normal distribution graph. Or also it is referred as a bell shape because it looks like a bell. That's why it is referred as a bell-shaped graph. So in this graph, if the p area which we are interested, your test area, that if it is occurred in left-hand side, then we can refer as a left-tailed test. And when this situation will occur, when if you are having in alternative hypothesis less than symbol, then or less than symbol operator, then you can able to get this particular test, that is left-tailed test. So opposite of that, you are having right-tailed test. If your alternative hypothesis is contain inequality symbol greater than, then you are able to get this right-tailed test. That means our interested area, that is p area, is occurred at the right-hand side of your shape of your normal distribution curve. It occurs at your right-hand side. That's why it is referred as a right-tailed test. And third kind of test that we are having is not equal to. So in your alternative hypothesis, if you are having not equal to symbol, then we are getting two-tailed test. That means your area, that mean value may be less than your mean value may be the less than, or it may be the greater than. That's why the area p area is occurred at both the side of your shape or bell shape or the normal distribution shape. That's why this particular test is referred as a two-tailed test. So up till this we have seen this much part. So any doubt in this? So are you able to get this? Yes, everyone. Those who have attended yesterday's lectures or today's. Okay, so we'll move towards next point. Now, how to identify the nature of the test? So there are some examples for this. So how to identify the nature of test, that is whether it is two-tailed test or whether it is left-tailed test or whether it is right-tailed test. So first example it is given. So you can see here, the university publishes that the proportion of its student who graduate in 4 years is 82%. So this is a statement that they have given. So how first our task is to form your null hypothesis, that is H0, and second task is you have to form your alternative hypothesis HA. So based on this particular problem statement, the null hypothesis is the graduates proportion is 82%. So 82 divided by 100. So actual value they are given, that is 0.82. But as it is expressing percentage, so you can directly write p equal to 82% also. That also it will be the correct. Not necessary that you have to write in 0.82 like this. You can directly write 82% here also. So in null hypothesis, the student will be graduate proportion will be 82%. Or the second possibility that it is not 82%. It may be less than 82%, like in 4 years 75% student will graduate, or in 4 years 96% will be percentage student will get graduate. So this is not equal to 82. So these are the two possible statement that we are having. So in your alternative hypothesis, it is not equal to symbol is contained or that particular operator is kept. That's why this particular test comes under two-tailed test. So you need to identify what kind of nature of the test you are checking for. So your P area appear in both the side of your bell shape or both the side of your normal distribution curve. So this is one example. We are having similar another example. A water faucet manufacturer announces that the mean flow rate of certain type of faucet is less than 2.5 gallons per minute. I repeat the problem statement. A water faucet manufacturer announces that the mean flow rate of certain type of faucet is less than 2.5 gallons per minute. So if you observe here, they are given the mean value, that is mu. In the null hypothesis at 0, it states that mu equal to 2.5 gallon per minute. Or it may be less than. Water, we are saying that it may happen that the water flow rate may be less than 2.5, but they have said that the faucet less than it is 2.5. That's why in alternative hypothesis, the mu is less than 2.5 gallon per minute. So here less than symbols is there. So this kind of test is referred as the left-tailed test because the P area will come at left hand side of your bell shape, or P area will be at your in normal distribution at left hand side. So this kind of nature of this test is referred as the left-tailed test. So there will be the another example of right-tailed test. So you see this cereal company, that is food grain company, advertise that the mean weight of your content of its 20 ounce size central boxes is more than 20 ounce. It is more than. That's why you have to, in alternative hypothesis, you are having mean value is greater than 20 ounce. And your null hypothesis is equal to. Always you remember the null hypothesis comes with equality symbol. An alternative hypothesis can come with less than symbol, greater than symbol, and not equal to symbol. So if it is come with greater than symbol, then that particular test is referred as the right-tailed test because your p-value area appear at your right side of your bell shape, or p-value area is offered at your normal distribution shape at right-hand side. That's why this particular test is referred as the right-tailed test. So these are the three examples for nature of the test that we are having. Now you have to make decision. So how to make decision in hypothesis? That decision is always based on the p-value. So you have to compare your p-value with alpha. So what do you mean by alpha? Alpha is nothing but your level of significance. So that value is fixed. That is, it is 1%, 5%, and 10%. That is, if it is 1%, then alpha value is 0.01. If it is 5%, then alpha value is 0.05. If it is 10%, then alpha value is 0.10. So this value, alpha value, you have to compare with p-value. So if your p-value is less than alpha, suppose your p-value is 50, 0.50. So you have to compare this value, and if your alpha is level of significance, you have selected as a 1%, that is 0.01. So you have to compare. If your p-value is less than your alpha, then you have to reject null hypothesis. If your p-value is greater than alpha, then you should not reject null hypothesis. You have to accept whatever you have made the statement in null hypothesis, then you have to accept that claim, you have to accept. So this is how we have to make the decision, and based on that we need to conclude our hypothesis. Now we will see the steps for hypothesis testing before solving the example. We will solve now today one example, one or two example based on this hypothesis testing. So these are the steps that we are having. Already we have seen these steps also. Your first step for hypothesis testing is you have to state mathematically or verbally, you have to identify null or alternative hypothesis. That means you have to make the statement H0 and you have to formulate the statement HA based on your problem statement. You have to first formulate null hypothesis statement and you have to formulate alternative hypothesis statement. That is your first step in hypothesis testing. Second step is you have to specify level of significance. That is, you have to choose alpha value, and there are three possible values. I said 1%, 5%, 10%. If not given in the problem statement, then you have to always choose alpha equal to 5%. Otherwise, they will specify level of significance is 1%, level of significance is 10%, level of significance is 5%. If it is not given, then you have to always choose alpha equal to 5%. Next, you have to determine the standard sampling distribution, or this graph, bell curve, or we can say normal distribution graph you have to draw. Then you have to find p-value. So based on your null hypothesis and alternative hypothesis, you have to draw this particular chart, whether it is p area is left hand side, whether your p area is at right hand side, or whether your p area is at both the side. That is two-tailed test. So that sketch you have to draw. That is your third test. Then your fourth step is you have to choose any test statistic. So you have to choose any test statistic. There are three test statistics that we are having. That is, you have to carry out three tests. Out of that three, one test you have to choose. That tests are nothing but Z test, T test, and chi-square test. So you have to choose any one test based on the scenario. If your sample size is greater than 30, then you have to choose Z test. If your sample size is less than 30, then you have to choose T test. If your sample population is not known, sample size is not known, your population parameter is varying, so then you have to choose chi-square test. So these are the three tests. Any one test you have to choose. That is your step number 4. In step number 5, you have to find p-value. You have to find p-value. So this p-value table is given. So this p-value table will be provided. I will show you this particular table. So this table number 1. So this table number 1, whatever it is shown, that is Z. So this table number 1 is used for Z test, and these are the p-value. For p-value 0.01, if you are you have to computed value for Z is 0.01, then how the p-value is selected? 0.01 indicate that if we are having like this. अभिषेक सर, तो कॅमेरा जरा ऑन करा.